No inside.
What is that?
There's
Yeah.
a big no inside.
Yeah. No, it's.
Yeah, because like they want you to use the other door, but
Yeah,
it's
yeah.
not really clear.
Yeah, that's. What is Hans?
I checked the
I can talk to an email, but I think you
right.
I just wanted to tell you I was right. It was at the hackathon.
Yeah.
That's I noticed that is why the
Just
I was there.
I can't present
Why not?
because I have this crap laptop.
Thank you. Were you looking for me,
Yes.
Mike?
I was looking for you. Please.
Why can't you present?
Because this crappy laptop doesn't have HDMI. So here is everything here. You don't have to
Go
know.
to restaurants.
Okay,
But I get obviously get this going.
yeah, just get going and you can go after that.
Yeah. So cold here, my fingers are totally frozen.
Yeah, it is. It's horrible.
Okay.
Yeah, I'll use it. Like if you want to go after that, that's fine. Yeah.
Okay. Start the firmware successfully, and then go to the IETF. IETF.
I have everything here. If you
Oh,
want.
okay. This is a USB stick. This
Yes.
is not a docket. Flash. Wednesday.
No, here. Here's the agenda. Oh, you want to copy it?
Better, huh?
Yeah, that's fine.
Send you a voice message.
Really?
You. Thank you.
I didn't send a voice message, but maybe I was.
Let me unplug it first.
Oh.
Oh, you did. Okay, so you can run this here. I turn off the chatty chat.
Yeah, close this. And I'll start. So maybe after that, that's fine.
Come on. Wait. And then, yeah, I think that's it.
Where is that? Oh. Why it's not here?
Over there. Why is it? Oh, maybe
Oh,
not.
maybe it's.
Let's turn it on.
Right, exactly. And so it used to just do that. Now apparently she'll say, I can laugh.
Okay. Sorry, guys, for the delay. Hey, let's get started. Okay, so this is the first session of two Oauth sessions. And here's the not well, so hopefully you're familiar with that already. So can I any minute takers? Anyone can help with that? Somebody that is not presenting today? No minute takers? Blue sheet or I'll. Do you see any blue sheets there? They are there.
Yes.
Okay,
This
yeah, okay.
We need, that's probably what this clipboard is
Yeah,
for.
yeah.
Is there a pin? It's probably another clipboard or someplace. There it is.
We need a pen. Pen here. Here.
Oh.
One, yeah, probably one is Wednesday, one,
No, so this is two different time periods for today.
maybe it's the previous.
We only have one meeting
Right.
today, so
Okay,
so much for the notes.
thanks. So can we get a Jabber scribe and a minute taker? Anybody can help with that? Minute takers? Nobody? No taker? We need somebody.
I'll go on Etherpad if I'm not the only one. Prisoners 11, guys, come on. No,
Okay,
I'm not going to be the only
Yeah.
one. Sorry.
okay. Anybody else with minute taker? Please. Thank you. And somebody in the Jabber? Thank you. Okay, let's talk about status here. So device flow, we will talk about that later today. Discovery, Mike will talk about that too. The JOT, I think we had some open issues. I think Nat sent an email response and closing those questions. So, Eker, do you think we're done with that, or you're satisfied with the? Oh, you want to take that?
Yeah, so my understanding, this is JAR.
Right.
Yeah, my understanding is that you guys have resolved those issues and I just have to go through and make sure that there's no more nitpicking floating around and approve it. And I just have dropped the ball.
Okay, thanks.
But I don't think so. I think there's nothing substantial.
Right.
And just since I'm here, I guess token exchange, if I remember correctly, there was some back and forth and do I have to read a new document?
Yep, it's waiting for you. Yep.
I'm a bad person.
Thank you. Okay, BCP we'll talk, or job BCP we'll talk about this later. And TLS, same thing. Security topic and token binding. All of those will be discussed later. Okay. So let's just quick update on the interim meetings. So we had two interim meetings to discuss distributed OAuth and reciprocal OAuth. It used to be called mutual OAuth. Distributed OAuth will be discussed later Wednesday. And with regard to reciprocal OAuth, we discussed this with Eker, and we have an approval to move forward with this. So that's an update on that, on the result of that discussion. Yes, published on the mailing list already, long time ago. Okay, workshop.
So we had OAuth, the latest OAuth security workshop last week in Trento. Here's a picture from that wonderful place there. We had, there's a separate workshop webpage, and I encourage you to look at the program, which links the slides as well as position papers that had been submitted to that workshop. We covered a number of different topics. Like in the previous workshops, we talked about formal methods. We had researchers coming along who did formal analysis, shared their experience. We talked about regulatory activities that impact OAuth. There was Thorsten spoke, for example, about the financial API and the work on the PSD2. EIDAS. We had deployment experience related talks, new ideas, also Mike, for example, did a thorough presentation on log off or log out. We also had crypto-related presentations. So overall, I think it was very interesting for me, worthwhile that we did this workshop. And it's good to get the researchers into the same room as standards people to have an exchange. And I was advocating for an increased use of formal methods in IETF security protocols as well, and played around it myself for one of the OAuth variants.
Okay. On the agenda, so we have Brian at the beginning to talk about MTLS and token binding. We have Torsten to talk about security. Dennis had three topics to talk about here. And we're hoping if we have at the end we have some time, 5 minutes, we'll allow Justin to talk about HTTP signing. If not, we'll talk about that on Wednesday. Okay, so Brian.
Thank you. Sorry. All right. Sure to read from. Thank you. That is London from some years ago, and we are in London. Yeah, you'll find many of my gratuitous photos in here, but yeah, let's get started. So just want to give a little bit of context, since I know everybody reads every single draft before they come in here. I want to give a little bit of overview that for someone that maybe hasn't. So what is the MTLS draft? It's two things, two primary things. One is doing mutual TLS client authentication, OAuth client authentication to the authorization server. And we've got two main methods of doing this. One is PKI based, where you check the certificate DN up to the, to a chained root, and the other is a self-signed method. And then there's also mutual TLS sender constrained access tokens for protected resource access. Another way to think about that is just these are certificate bound access tokens. Slide. So why are we working on this? Mutual TLS client authentication, which is something that obviously provides better security characteristics than the shared secrets in the normal OAuth, is something that's been done in practice for OAuth from a lot of vendors and implementations for quite a while. We've never actually had a standard to support it. Mutual TLS sender constrained resource access is something that binds access tokens to the client certificate, so they can't be played or replayed by any other entity without the private key. This is, actual proof of possession access tokens, which is something that's been a little elusive to the working group and the community at large. I'm told that banks need these for API use cases, being driven by a variety of new open banking regulations. They want stronger forms of security, but they want to also be able to use OAuth. And this draft, even in its draft form, is currently referenced by the OpenID Foundation's Financial API Working Group, FAPI, in their read and write API security profile, which is a higher security profile around OAuth, as well as being referenced in the UK Open Banking API security profile. So despite being in draft, they're already being referenced. Sorry, you can jump ahead. I was talking over you.
Sorry.
No, that was me. Next one, though. Okay. So how does this stuff actually work? The mutual TLS client authentication is obviously the authorization server, typically the token endpoint, but also any other endpoint at the authorization server that might require client authentication works the same way. The client, the TLS connection that the HTTP request is made over is established with mutual TLS client certificate authentication. The client also includes the client ID HTTP request parameter in all requests of the token endpoint to identify itself up front. And the authorization server verifies that that certificate is in fact the right one for the client, and that's based on configuration and/or dynamic registration information around that particular client that the AS has. And then there's some metadata supporting this that would be used in dynamic registration, and/or, as I think we all have come to learn, the metadata basically implies the client data model, so it can be used even in the case that you're not actually doing client registration. So there's a new, for the PKI method, there's a new authentication name. That's TLS client auth. That could be used both for the client to indicate what authentication method it's going to use, as well as the server to list which methods it supports. And then in client metadata, there's this TLS client auth subject DN, which specifies the expected subject distinguished name of the client certificate. And then there's metadata also supporting the self-signed certificate method. And that's an authentication method name, unsurprisingly, of self-signed TLS client auth. And then the existing JWKS and JWKS URI, really an OR, metadata parameters can be used to carry the client keys and certificates or hold them. And just maybe it's not clear, but the difference between those two methods is that in the former, the PKI method, the client presents a certificate, the authorization server, validates that that certificate is signed by a trusted authority that it trusts, and then checks the subject DN against that which was configured. So it's sort of more of a traditional PKI approach to authenticating the client. Whereas in the self-signed certificate method, the client just presents its own certificate, self-signed, and basically the authorization server has trust chain validation turned off at the TLS layer. So it proves possession of the key, but it doesn't actually validate the certificate chain. And then the authorization server just matches up the raw keys or the certificate to what it has configured for itself. Okay, next slide, thank you. Okay, so how does mutual TLS sender constraint access work? It's hard to find a right name for this because token binding kind of means something else entirely, as Torsten has mentioned to me a few times or misstated. But basically, this is binding the access token to a client certificate. So either mutual sender constraint access, which I think was a term Nat came up with, or certificate bound access tokens. The wording's kind of used a little bit interchangeably in the draft, hopefully in a clear way. So on issuance of an access token, the authorization server associates a hash of the certificate with or into the access token, thus binding the access token to the certificate. The TLS connection from the client to the actual protected resource is over mutually authenticated TLS, and the protected resource matches the certificate obtained from the TLS layer to the certificate hash in the access token. And obviously, if they don't match, it's rejected. If they do, then proof of the corresponding private key has been proven, and this token-bound or certificate-bound access token has been used successfully. In order to carry this information in JOT, we've got a new confirmation method, which is the X509 certificate SHA-256 thumbprint confirmation method, X5T pound S256. This just carries the SHA-256 hash of the certificate itself. And then there's a confirmation method also for token introspection that's exactly the same, looks the same name, same semantics. It's just conveyed in the token introspection response rather than a JOT itself. And one, I think, benefit or maybe not obvious side of this is that the token binding piece of it that binds it to the certificate, it doesn't vary based on the client authentication method. So the actual access token is bound to the raw certificate itself, and the resource or protected resource doesn't have to have any knowledge of how the actual client authenticated the server. It just needs to verify that the key indicated in the access token matches the one that the client presented in the TLS negotiation. And there's just examples of the two here. I'm not sure if you can see them very well, but it has the confirmation method with that particular what do we call it? Confirmation method name or member inside of a JOT as well as inside of a token introspection response. They looked similar, unsurprisingly. All right, next one. So few changes since Singapore. Published draft 6 and 7, not sure which was in each, but a sort of an overview of all of them. Updated to use the RFC 8174 boilerplate, which is just a little bit more wording around the normative language that is being recommended pretty much to everybody now. So I went ahead and did that to get a head start on it. References update, including the authorization server metadata or discovery document. I moved the security considerations up before the IANA considerations. I'm not sure how I got those out of order in the first place, but it looked really weird in the document. Most people stop reading when they get to IANA, and the security considerations here are actually pretty important. So I thought it'd be better for it to be with the rest of the text. I talked a little bit more about certificate bound, access tokens in the abstract. That part was not not really conveyed in the abstract very much. I thought it'd be worthwhile to spell that out more, so someone reading the beginning of the document could know there's sort of two main components to the document itself. Did something similar to the title. It was just called MTLS Profiles previously, which I guess is accurate but kind of meaningless. So the new title goes on to basically say that's for client authentication and certificate-bound access tokens. Added a tiny little bit more text in the security considerations around certificate spoofing or preventing certificate spoofing based on a constrained set of CAs into the security considerations. That was suggested by someone at the last meeting. I did add an explicit note also from the last meeting this came up that the implicit flow is not supported for obtaining certificate-bound access tokens. And finally, added an appendix section describing the relationship of this spec, the MTLS spec, to OAuth token binding. Since there's some overlap there, I tried to explain the situation and why they both exist and why at least you might consider one or the other. And those are all the changes. So next slide. So what are the next steps? Looking at the minutes from Singapore, there was this statement that the working group last call will be issued in December after clarification. And that clarification was actually that note about token
let's
binding.
do it a little faster and not wait till December.
Different December. And so with that, I'm sort of urging that we consider working group last call at this point.
Yeah, I think so. Yeah, that's what we're thinking right now, and we want to see if anybody objects to that or if you have any issue with that. Like I think we're probably ready to go to work group last call on this one.
We have the technology. All right, Justin Richer. I actually don't object for this to going to last call. That you didn't give me any other option. I wanted to talk anyway. But no, I do think this is ready for last call. We actually just over the last 2.5 weeks or so have gone through and implemented everything in this draft. So both authentication methods and the sender constrained access tokens, the non-bound TLS bound access tokens, whatever they're called, right? We implemented all of those in in what's going to be a forthcoming product for one of my clients, Oauth. So that's so there is going to be at least one implementation in the wild. I know Ping has some implementations as well. I don't know, is ForgeRock on the ball on this yet? Guess not.
No.
Would you like to go on the record?
Mutual TLS. Go.
That's very.
Guys, you're off mic.
Torsten, yes.com. There's another implementation. It's the Nimbus library and the Connect to ID product. We use that at yes.com, and we use it in two ways. We use it to actually secure our microservice-based architecture and directly for the OpenID Connect access for line parties. So from our perspective, that's ready to be used. Another note, besides the two references you gave on the first slide from the FAPI working group and the Open Banking UK, also the Berlin Group's API specification for Payment Service Directive 2 directly references this draft.
I did not know that. Thank you.
Okay, go ahead. No, go ahead.
Yeah, so we just had a short discussion. I think we will start a working group call, last call today even, because it will give us an opportunity to hassle some of you to actually do that during this week while you're here. Next week you will be super busy catching up with your company internal work. So if you are interested or if you have time to review this document, I think that would be, please come forward. It won't take too long. We did look at it for the last meeting to see at what state it is, and with the clarification that you provided, I think it's very good. That's what we've been asking for last time. So, and would obviously work with Eckhart to get this through the process as quickly as possible, given that what we learned at the workshop, that there's dependency from some of the open banking initiatives that want to use this work. So definitely a new field where OAuth is used and hasn't traditionally been used. So we are spreading out OAuth in all sorts of new domains, which is excellent. Thank you, Brian.
More documents, Zucker.
Okay, next one.
Yeah, another one, right?
Justin, you'd mentioned you had maybe a nit on an understanding. It can be on the mailing list in the last call. Though.
Yeah, we can do it on the mailing list, or I can just tell you. It's minor potential wording clarifications, nothing normative, purely editorial of I garden pathed on a couple of things during implementation, but I'm pretty sure I came up with the right answer. So
If they can
the information's there.
Yeah, if it can be clarified, then just do it.
So who of you could be or is willing to take a look at it besides Justin during this week to actually or next week to provide some review feedback?
Apparently, I've been volunteered, so okay. No,
Well, you have already looked at it, so
I have, and I will do a close comb over the document and come up with nits and things like that.
Mike Johns, it matters, so I'll read it. Torsten should read it too.
Yeah. He's,
Okay. Well, you should still read it.
yeah. Torsten was in write-only mode. Eve, do you have time to take a look at this document? Cool. Okay, next topic.
Yep, next topic. So this one, oh, we're already there. Thank you.
Is that okay?
Yeah. Sorry. I was confused. So this one's going to be hopefully kind of short because I know there's some other things added to the agenda that I want to leave some time for.
And actually, there's a big screen, so you can.
I know, I'm not sure which one to look at. I'm sorry, I'm kind of dancing. I'm nervous. It is what it is. All right. OAuth 2 token binding. That's also London. Here we are again. Yeah, next slide, please. So just want to give a little bit of an overview of what token binding is for those of you that may not be familiar and haven't followed that working group. It's something that enables a long-lived binding of cookies or other security tokens. That part, the other security tokens are the ones that are interesting to this working group, to a client-generated public-private key pair. The use of token binding is negotiated in the TLS handshake with an extension, and then assuming it's negotiated on all subsequent HTTP requests over that TL connection, possession of this client-generated key is proven by signing the TLS exported key material, the EKM, and then sending that along with the public key basically as an HTTP header in every request. Cookies and tokens can be bound to that key. I think I said that already. And the key, at least in the web browsing case, the key is scoped to the effective top-level domain +1, so there's not a privacy issue necessarily. They're scoped basically the same way that cookies can be scoped, so they're not set any broader. It's not like a super tracking cookie or anything. And then this idea of federated or cross-domain use cases, like OAuth, where the resource server might be in a different top-level domain than the authorization server, are supported via this thing called the referred token binding versus what's normally called the provided token binding, which is a way for in that HTTP header to send actually two different token bindings, two keys, and prove possession of them so that the issued token can be bound to the other key, which will be used for connections to some other service like the resource server. Next slide, please. So just really quickly in a nutshell for context here, what is this document? It's basically a way to provide an OAuth 2.0 proof of possession mechanism based on the underlying technology of token binding. That's to defeat, replay or play of tokens by unauthorized entities, including a resource server replaying it or a lost or stolen token being played by another, impersonated client. All these things are prevented to the extent that the private keys are protected. There's a few different types of tokens in OAuth. Turns out there's actually a lot of tokens in OAuth, so we try to bind them all. The most interesting one is binding of access tokens using the referred token binding ID. So when you request an access token, when the client requests an access token, it presents two token binding keys, and the authorization server binds to the second one, which is the key that'll be used when making actual protected resource requests. And we also have a representation in JOT for this based on, or not based on, but as an additional confirmation method member, this being the TBH, token binding hash member, and it's just a hash of the token binding ID, which in turn is basically the public key. And that also is available or will be registered for introspection responses. We also talk about how to bind refresh tokens to the normal token binding key. There's 2 ways to bind authorization codes, one for native app type clients and one for web server clients. And then finally went on recently to add binding for JWT-based authorization grants and JWT client authentication. And so in summary, the changes since Singapore, draft 6 was published, also using the new boilerplate, really trying to get ahead on things with that. It's an exciting change. Updated some references to the draft token binding and discovery. I think one of these is already out of date. And made a few, maybe just 1 or 2 really minor editorial fixes. So nothing really substantial has changed in the document. So it's still there. Next slide. And so trying to look ahead, the underlying 3 token binding drafts should be going to RFC. This is, I think, the 3rd time I've said that.
Let's see how long things take no, I think didn't. So the article what happened. I'm working on it. Was that up? Oh.
There's one behind you. I think they're close, but
So as I recall, what happened is the non-HTTPS ones were fine, and I was done with them. And then Dirk had to produce an HTTPS one, and that came in about a month ago, if I remember correctly. So I just need to finish that, and then we're good.
Microphone.
So IETF last call has been completed on that, and it's waiting for your write-up.
Did it really? Did I screw that up?
Oh, okay. Then I can do that really quickly.
Thank you.
that was easy. And then, beyond that, we really need implementation experience and feedback on this stuff. And I think maybe Justin will appreciate this. This stuff should be really easy once all the really hard parts are done. And the really hard parts are that this token binding itself sort of crosses over layers that aren't typically crossed over by your average developer. So you need access to pieces inside the TLS layer that aren't always easily available. So there's really sort of either some really, really heavy lifting hard work to be done to make it work, or a waiting game to get lower level platforms to surface the APIs and expose the functionality needed to do this. And I'm hopeful that as stuff progresses to RFC status, maybe that'll become available more soon. But without that, actually doing implementations is really difficult. And it's an unfortunate state we're in, but it's sort of a chicken and egg problem, if you will, or rock in a hard place. I don't know, your favorite cliche there, please insert it.
So let us get an idea on where we are with this. So you've been working on an implementation, and you have gained a lot of experience in that regard. But unlike many of our other specifications, which had lots of implementations, also product implementations and even deployments, that seems to be a little bit on a different level now. Mike, you guys have an implementation?
Microsoft has and has deployed implementations of parts of it, and it's working in production.
That's fantastic. Yeah. Okay, so that's at least
it's something.
It is definitely something. Yeah. But we had cases where we had reported in our document write-ups and like 10, 15 plus implementations. So we are this is definitely at a different level here.
Yeah, we're not there yet, for sure. And even the work that I've done has been largely at the lower layer, trying to make that happen in the platforms that I use. And
do we know how we could improve the situation or get there eventually? Because you know better what is needed from TLS stacks in the different environments, and so we could reach out to those guys to actually make this happen also.
Largely, I think there's a need for the various sort of TLS layer APIs to expose mechanisms to do arbitrary extensions, as well as expose access to the exported key material, that's in some places and not others. In some places, make it very difficult.
Mike Jones at Microsoft. From my point of view, the biggest thing that we can do to accelerate this is just get the token binding specifications to RFCs.
Yeah.
Currently, different implementations are implementing different draft numbers, and therefore the one that's on by default in Edge is not talking to the same services that Chrome is, because they're different numbers. And so once, Eric does his write-up and we have 1.0, that unblocks a lot of developers from feeling like this is real, we will do the library work. I know that inside Microsoft, some things are happening, but some things are waiting till we have 1.0. Thank you, Eric. You're a good man.
Okay, thank you.
That's all I got. Thank you all.
Thanks.
This is amazing. Hi, I'm Thorsten. I'm with yes.com, and I happen to be the editor of the security topics document. The security topics document is basically an update to RFC 6819. That's the security threat model and considerations document for Oauth 2.0. Because we figured it was time to gather and capture all the security threats, implementation issues, security relevant implementation issues, and the lessons learned over the course of the last couple of years. Next slide, please. So basically, the document tries to give an overview on the current Oauth security topics, open security topics, and tries to systematically capture and discuss the threats and respective mitigations. The goal or the objective of the working group is to turn this into a security best current practice document and to provide implementers of Oauth, client side as well as server side, with recommendations how to implement Oauth securely or even secure. Next slide, please. So this is how the document looks like. The majority of the sections describe different threats, implementation issues, and give different options how to mitigate this threat. So, for example, there is a section on access token leakage, and there is a comprehensive discussion of what options exist from our perspective to actually cope with this kind of threat. So, for example, sender constrained access tokens, audience restrictions, and so on. And then in the end, we distilled a section containing recommendations that we give to implementers. For example, in this case, regarding token leakage, the working group decided that sender constrained access tokens, either via token binding or MTLS, would be the way we would recommend, because this is the most reliable way to cope with this kind of issue. Next slide, please. But nevertheless, we gave the whole discussion so everyone can give it a read and come up with his or her own idea. All right, so this is a selection of the recommendations we are giving to implementers. That's just a selection. So the redirect-based flows are a very important part of this document. So for example, we recommend exact redirect URI matching. This is something that OpenID Connect required implementers from the beginning, but Oauth was a bit more relaxed regarding that perspective, which in the end, this flexibility opened up a lot of issues regarding open redirections and so on and so on and so on. So now we decided it's better to go that way, to recommend exact redirect URI matching, because it's a good foundation for having a secure solution. And there are other recommendations that we give, for example, to mitigate code injection attacks. Implementers are advised to either use PXE challenges or the nuns in case of OpenID Connect or PEACE to prevent this kind of attack. Next slide, please. Okay, what happened since Singapore? We published a new revision. Actually, I published a new revision yesterday, and it's complete now from our perspective. So we completely reworked the section on code leakage and completed a section on access ref, referrer headers, and so on. I decided to remove the section on refresh token leakage just because there is nothing new to report, right? So refresh token leakage prevention is already covered by the security consideration sections of RC 6749. So we don't need to update that. And we added a section on open redirection based on a draft that John has published previously. So
you copied that text in there from that draft, or what did you do?
No, I took the liberty to enter a distilled version of that. Just a brief description of the thread and a recommendation how to cope with that. Because the open redirection draft also gives additional threads that we are already covered in other sections of the document. So, I mean, I would hope we will have another review round now, potentially a working group call, so people can check it and give us feedback on that. What we also did is we removed all the text around this being a working document, helping the working group to keep track of the current status of the discussion of the different security open topics, because we think we are done for the moment. For the moment, I mean, we decided to make it a BCP to be able to update it frequently, and I hope we will do so on not again wait for how long? How long did we wait? 5 years?
Okay, hopefully not.
Yeah, I think so. Yeah. So it's a BCP, so we are ready, and I hope it will become a BCP, so we are well equipped to update the document on a more frequent basis. From my perspective, the document is ready now for working group last call, and yeah, I would ask you to do that.
So obviously nobody has read the version that you just posted. That would be a stretch, but
Andre and John read the version.
Brilliant. Okay, that's very good. How many of you have read the earlier version or the latest version? Raise your hand. Oh, it's 2, 4, 5, 6, 7. Yeah, 7, 8. Yeah, if we wait a little bit longer, probably 10. Then that's pretty good.
That's good.
So I guess we should have a few guys reviewing, posting or doing the review, posting something to the list before we start a working group last call on that one. There's some new stuff in there. So do we have some volunteers to review this document? Tony? No. William? Okay. Someone else? Brian, you have?
Yeah.
Okay.
Come on. Yeah.
Did we have someone else?
The name, please. Did you get the name?
Okay, Travis Spencer.
Oh, Travis. Okay. Thanks, Travis.
Perfect. Thank you.
Okay, that's it.
Yeah, go ahead.
Okay.
You start with this one? It's good.
Hi, everyone. I'm William Dennis. I work on Google Cloud. Here to give 3 updates today. The first is the device flow. This will be the shortest one. So let me just quickly recap for anyone that hasn't seen the device flow specification. This is an authorization flow designed for devices that have an internet connection, but no browser or limited input options. So the classical example is like a TV app like the YouTube app. And in this flow, the user actually reviews the authorization request on a separate device, and they can approve it there, like a mobile phone or a laptop. So the TV or the device would show a screen just like this, directing the user to go to an authorization URL and enter a code. The user then loads up that URL on their separate device, such as their phone typically, types in the code, approves the OAuth request, and then the device can get its tokens. There's one additional optimization which we've added in the standard, which is to allow for like a QR code or any kind of non-textual verification technique. This was presented separately to the kind of manual instructions, allows the user just to scan the QR code. And then typically they wouldn't have to actually enter the user code, but they might confirm that it's the same code just to avoid kind of phishing risks. So what happened since 07, since the IETF 99 presentation? I don't know if anyone did an update the last one, but I missed that one. But what we've done since then is we standardized on the complete form of the verification URL. Those who were there may remember a discussion. We were debating whether or not to have a kind of composed URL where we would actually add the verification URL and the user code kind of in like a sort of structured, composed way. That was rejected in the end, and we've just adopted this simpler kind of option where the authorization server can just provide the complete verification URL for that like QR code optimized option. We also added some security considerations around spying. That was at Nat's request. So that's just covering the case where there could be someone, behind you watching all your interactions. Given this is on a TV, they could be like at the back of the room or something. And we added some text to explicitly require that the device code is actually not shown as part of this, just in case that wasn't clear. Plus the text regarding the minimum polling intervals, so we don't DOS and take down Justin's server again. And then just posted this morning, but there was a diff posted approximately 2 weeks ago. Just a minor clarification around the entropy guidelines for the user code. So this is an interesting code because it's actually part of the user experience. The length is kind of constrained by what you can reasonably expect the user to type, and the char set likewise. So we just added a little bit of a clarification around the trade-offs there that the authorization server needs to take into account. And we also document, the risks of a low entropy code there. If someone were to be able to kind of brute force that user code, it kind of puts them in this sort of reverse takeover situation where, like, normally if you brute forced an OAuth token, you would gain access to that grant. In this case, if you actually brute force the user code, you have given the victim the grant, which would be to your account. So it's kind of like a reverse takeover. Now, it probably doesn't make sense for kind of like the Play Movies YouTube type flow, or make much sense, because then the victim would actually be able to buy things with your account. But there are certainly, very valid concerns still with that attack, such as the attacker still may be able to actually control that device. There's also the privacy issue that the attacker could see, things that the user is actually then doing. So it's definitely worth considering. So that text went in on version 08, which I believe resolves every single outstanding question, and I think we have already concluded.
Yeah, so this is already with Ecker. So, but we're gonna update the draft, that version with this one, just to address that comment, the last comment that we had. But otherwise, it will be with Ecker after that.
So I actually sent some comments about this, and I just got an email from John like 14 minutes ago, which I'm struggling to assimilate. So, yeah, I guess I'm concerned about whether or not there's an attack pattern here. So I guess, did I send an email? I sent it to the draft authors. So I guess I'm not sure the best way to resolve that now, because I'm having trouble assimilating John's message in the middle of like listening to this. Do you want to discuss it? Should we have a side meeting? Shall I read it like tonight and come back to you? What would be the best thing to do?
Let's discuss it.
Yeah,
Let's discuss it. It's a good time.
Okay. So
The very short answer is yes.
Microphone.
So the very short answer is yes, you did actually identify a confused deputy attack. Gold star. So the attack is only possible if.
Can you explain the attack for those people who hadn't seen that?
Right. So the idea is that if the device is an OAuth client. If it's set up to talk to an OAuth server, and that OAuth server is compromised, i.e., is compromised or inherently bad. So assuming, just for the sake of argument, so that people understand the attack, I'll use real company names, but that isn't to infer that there's anything nefarious about them. So if you had a Roku device which uses this kind of flow for binding media subscriptions to it. So if Netflix were compromised, i.e. their OAuth server had been taken over by a malicious person, that OAuth server, when it receives the request from the Roku, when the person clicks on the Roku or clicks on the Netflix picture in the Roku, would then start off the flow to Netflix. Netflix would then go, yes, but now I can go to Amazon Prime Video and get their highly prized access token for this user at Amazon Prime. So it would go and get the challenge, get the user code, etc., pass that back to the device, the Amazon one back to the device. The user would then see on the screen, please type in amazon.com/prime/authenticate or whatever the URI is, and they would go there and they would put in their Amazon credentials, and then they would see a box that came up, please enter the code that's being shown on your device, and they would put the code from the Roku into Amazon, which would then enable the bad Netflix polling to then get the appropriate access token. So essentially the user would think that they're logging in to start off the flow thinking that they're logging into Netflix, and if they weren't completely on the ball, they may wind up at an Amazon screen, put in their Amazon credentials at Amazon. So Netflix wouldn't be getting their Amazon credentials though, since they've used the same username and password both places. It's probably moot. They would get the access token for the Amazon Prime service. So I mean, it's unlikely that Netflix is going to attack Amazon, but in
you can
principle,
easily see how that would work with other services. So
yeah,
you're
so
essentially as good as the lowest common denominator.
Well,
Willing to log in with figure dumb enough to help fix the guy that's back there. Some of those
the weakest guy that the device manufacturer has allowed you to log into, because
yeah.
You might just be like, and that's probably the more persuasive version.
Right. So I helped John work on that text that you got 14 minutes ago. I added the point that for this to happen, either the device manufacturer is the attacker, in which case you probably didn't want to buy their device, but that or they're trusting an authorization server that is the attacker or became compromised. All of which is possible, but there's reputational things where, you would get a bad write-up about your device. Now, William wrote some text in security considerations earlier about trying to inform end users that what you are doing now is authorizing use of your Roku device. The reason you want to tell them that is if software has been in the middle of the whole thing or something and they don't actually have a Roku device, maybe that's a red flag. And we made an offer to beef up 2 of the security consideration subsections to discuss this confused deputy situation.
Yeah, I mean, my sense is that this is done constantly and we don't know how to fix it other than what you just said. And so not writing it down is not helpful. Not publishing the document because we have this problem is not helpful. So I think what I was expecting, given I understand it correctly, is for you to improve the security considerations, so it makes it clear what's going on, and then we can move forward. I don't think if I know how to fix it, I'd be pushing to fix it, but I don't. So there we are.
Sounds good.
Yeah, I think the editors agree, and we'll do that.
Great. Thank you.
Perfect.
So in terms of running code, there's a bunch of examples now. And the most recent one I heard about was Yahoo Japan and the AirStick 4K, which have implemented this flow. That adds to the MITRE ID open source server implementation. We have a client here, proof of concept, and of course Google actually implements the server one as well.
Yeah. The Shepherd write-up also contains further examples, but we'll update that.
Great.
Yeah.
Okay, thank you.
Which one do you want to talk about next? App incremental or device posture?
All right, now for something new. Well, a little bit less new if you're here at IETF 99. But okay, so Oauth to incremental auth. Let me just give a bit of a recap in case you haven't heard of this before. So the problem statement that incremental auth is trying to solve is that effectively asking for the kitchen sink of scopes upfront is a bad thing. And users should have the context of what they're authorizing when they authorize it. So a good example here is if you have an app that, say, combines an identity-related scope, such as with OpenID Connect, it might combine like a calendar scope for some kind of calendar integration and, say like a email scope for some email integration. The user shouldn't be presented an authorization request at sign-in time asking for all those three things. They should just be presented with the thing that they're doing at the moment. So a screen like this is kind of the antithesis of what we're trying to get to. These apps really shouldn't be asking for all these things, even if they actually need them to kind of implement all the various features in the app. Each of these scopes should probably be requested separately when it's actually needed in the context that it's needed. So the definition of incremental auth is the ability to request additional scopes in subsequent requests that results in a single authorization grant representing all the scope granted so far. So without incremental auth, you would effectively just have, if you did multiple authorization requests, you would just get multiple authorization grants that you would have to maintain separately. And so the benefit of incremental auth is that it merges them into that one single authorization grant representing all the scope that's been granted so far. So a typical implementation of this would be where the consent screen would only display the new scopes. So if the user has already granted scope A and the app would ask for B, it would typically only show the new scope, scope B, or at least it would show the scope slightly differently. And then a single refresh token is issued for the union of all the granted scopes. So this is actually possible today with a confidential client in Oauth, what I call a kind of de facto incremental auth. And the reason it's possible is that Oauth actually doesn't stop you returning authorization grant with more scope than what you requested. So in the case of a confidential client, if the user has already granted access, it's kind of plausible that you could actually return that access on a subsequent authorization grant, given that the client in this case is actually authenticating. However, no such thing existed for public clients. So what this specification really introduces, and the kind of key point of its existence, is a public option, a public client option for incremental auth, also called appcremental, for which I apologize. This consists of a new token endpoint parameter called existing grant. And how it works is that if you've already done one authorization grant with some scope, you can then do a second authorization request requesting different scope. And then when you go to exchange the authorization code for the tokens, you can actually pass in the existing grant at that time. And what you get is kind of a merged authorization grant. That's why the parameter is called existing grant. Here's a sequence diagram just showing the first request, the response. The top half is very typical Oauth there. And then the bottom half is again very typical Oauth, just with that additional existing grant scope. The existing grant, which is the refresh token from the first part being passed in. It's really very simple set theory. It's just you take the grant A and the grant B that were done as separate authorization requests and it unions them together. Nothing more than that. So if you didn't have this specification, the native app would be sitting there with both grants separately. They'd have to maintain those two refresh tokens. They'd have to refresh the two refresh tokens and kind of just keep track of things. With this, they get a simplified view of the world and they just get one. So in terms of running code, this has been implemented on Google's authorization server, so you can actually try it out today. I have a proof of concept code there using AppAuth. It's a fairly minor modification. We also have a demo. I don't know if you want to run the YouTube video here.
How long is that?
1 minute.
Okay.
Let's go full screen. Yeah. So here the user has performed the first authorization request. The user granted access to calendars. We do a token exchange. Let's introspect that token, and you can see here that the scope was granted to calendar. We then do a second authorization request. In this case, it adds the blogger scope. The user has allowed that. We're going to introspect the resulting token, and you can see that both scopes are included. So this is running off that proof of concept code I put a link up to earlier. All right. Okay, and so in addition to the public clients, the specification also documents some best practices around confidential clients. It also includes this new parameter for confidential clients. As I mentioned, it is possible to do incremental auth with confidential clients already, but perhaps that behavior of returning more scope than was requested is not always expected. So this extra parameter just allows the user to actually control whether or not the request will contain the full scope that's already been granted or not. All right, so what's changed since IETF 99? Basically, based on the feedback, then I added a whole bunch of sections, security section, privacy, one on usability, and also documented some alternatives. So that's incremental auth. And yeah.
Yeah. Okay. Do we have people that reviewed this? Do we have anybody that reviewed this document? Any comments on this? Who reviewed that document? Anybody here? 1, 2, 3. I'll wait.
Hi, Justin. I have not implemented this one yet. I did read through it. I think it generally makes sense. I think that there's ways that it can be clarified and stuff like that. I don't think it's done, but that's not what you're asking. It is, I think, an important concept, and it's something that people are doing today in weird proprietary ways anyway. I think that this is something that we can do to encourage people to not ask for, as you put it, the kitchen sink, or I think as Torsten and I used to call it, the Uber token, right up front. He says it better.
No, Justin, I just said you invented this term, Uber token.
Okay, I thought you did. Anyway, so no more Uber tokens, I think, is a good thing, or at least minimizing the Uber tokens, kitchen sinks, whatever the metaphor is. So yes, I do think this is a good document that we should move forward with.
John Bradley. I think it's a good document. We should move forward with it. There's probably additional security considerations that we have to dig into, like, was that refresh token actually for the same subject or resource owner as the new one? So there are implementation things that people may get wrong that we have to sort of think through some of the new issues. It would be better with token binding, obviously, so that the refresh token was actually bound to the client. So there's a few things that need to go into it, but other than that, I think it's functionality that we did have can largely replicate with confidential clients, but this allows us to have public clients do the same thing, which unfortunately some of the OAuth implementations do, and it causes incremental auth currently with public clients causes all sorts of interesting side effects, because you wind up authorizing a client on one device for something, and all of your devices, all of this with the same client ID, wind up inheriting that privilege, which is also unanticipated, but I've seen in the wild quite a few times.
Right. I guess I should have explained that was why you can't do incremental auth with a public client. At least you shouldn't. I guess you can, but you shouldn't for that reason.
Okay, is there anybody that thinks this is a bad idea? Okay, so maybe we'll ask for, or go for a hum and see if the group is willing to adopt this draft right now. So I'll ask if you're willing to adopt it and if you're against adopting this draft. So if you are for adopting this document, please hum now. If you are against, please hum now. Okay, thank you. That was good. Yeah.
So to summarize, people are in favor of adopting this. Can I also write down a few reviewers? So we'll obviously have to confirm it on a mailing list, talk to Eka about the milestone changes. Few hands to review. I see Justin, Thorsten, John as well. Yeah. Excellent. Thank you.
Thank you.
Oh, is it dead? Oh, maybe it's dead.
All right. Well,
Let's try down the one.
switch them out. Let's see if there's batteries.
Yep. Testing.
It says, it literally says dead battery.
Okay, so thank you for your attention so far. This is the third topic, and this one's device posture. So I think John may have presented this a couple of times previously. I'd like to give a crack at it and see if there's some interest in this document. Let me start with the use case. So this document is designed to address a specific use case, and that's this BYOD phenomenon in enterprise. Bring your own device. So this is where an enterprise wants to allow its workers to just bring their own devices, Android, iPhone, whatever, into the enterprise and use their personal devices with corporate resources. At the same time, users are sometimes a little bit hesitant to allow kind of these invasive mobile device management certificates on their devices. Mobile device management is sort of traditionally how the enterprise could secure those devices once they're brought into the enterprise environment. But it has a significant drawback that the enterprise can typically remote wipe that device. So this is kind of a very uncomfortable feeling because you've got all your personal data on there, like your photos, and you don't necessarily want your company to be able to wipe that. And secondly, there are certainly privacy concerns as well in the sense that it gives the enterprise the ability to read certain data off the device, which varies case by case, but it's also less than ideal. Despite that, the enterprise typically only really cares about three things, or they at least care about these three things. They care that the user has a lock screen enabled on their device. They care that the operating system is up to date. They care that the phone is not rooted or jailbroken. The reasons behind this is that for the first one, they want to make sure that if the user just leaves the phone at a bar, that the next person that picks it up can't access the company resources. They want to make sure that the operating system is up to date to make sure it's patched against vulnerabilities. And they want to make sure the phone's not rooted or jailbroken to ensure that the software on the device can actually be trusted. So rather than the heavyweight mobile device management solution that gives the enterprise control over the device, like remote wipe and being able to access certain data, device posture signals are an alternative to that can be used to communicate the device's compliance state to the authorization server. And it works like this. The device posture signals are simply bits of information that get sent along with the authorization and token requests. And it allows the authorization server to make informed decisions based on those signals as to what the user can access of the corporate resources. The spec creates an IANA registry for the common signals that we're defining, which are then sent in a JSON dictionary like this example here. As you can see, that a lot of the data, it's just booleans and strings. It's kind of very simplistic. There's a missing slide here. So this data is then sent in the authorization request as a hint called the device posture hint. This allows the authorization server to guide the user into a more secure state. So for example, if the user requires a lock screen and the signal on the authorization request says they don't have a lock screen, because the authorization request is like a user agent flow in the browser, the authorization server could say display an error and say, hey, you need to go set up a lock screen. That's sent on what's called the device posture hint. Then on the token request, the same dictionary is sent again. The reason it's sent on the token request is that unlike the authorization request, this one can't be modified by the user in the user agent, so it's a little bit more safe from that perspective. And then it's also sent, that same JSON dictionary is sent on every token refresh to ensure that the device remains compliant with any of the corporate policies. So from an app adoption point of view, the good news is that not every app would actually need to implement this for it to be effective. As long as you're actually using RFC 8252 style authorization, where you can actually tie all of the devices grants to a single session, then you really only actually need one app on the device sending these signals for it to be effective. It can apply to kind of every app, or it can apply to the session on that device. So that's the good news as far as adoption is concerned. You really need like a handful of apps to implement this of the enterprise suite for it to be effective. In terms of what protection this offers, you probably noticed earlier that these were kind of unsecured strings and booleans. There's no kind of cryptographic security around it. So what good is that, right? Well, it's this. The goal here is to protect honest users who may be hapless, but they're generally honest. So this is the user that is not trying to steal corporate data, but they might leave their phone at a bar. It can protect against that use case because that user is not lying about their client state, is not modifying their clients, and this will help them get into a good and more secure state. It's not designed to prevent authorization tokens being issued to dishonest users, someone who's actively creating like a spoof client and trying to obtain an authorization token. That is not the goal here. However, it might actually be possible to create a robust, unforgeable system if you combine some advanced techniques such as token binding along with device attestations like safety net. This is supported by the spec because the spec is just defining key value pairs of signals. So it is possible to encode this type of information in the spec. It is technically out of scope. We're not trying to establish the exact way to do this. And John Bradley has all the details if you're interested to learn more about that. Maybe. Okay, so that's device posture signals and the reason that we're proposing that.
Ask us some questions before.
Yeah, and maybe if they have implementation too, right?
Yeah. So let me start with asking on who has looked at the document, read the document. Okay,
Sorry, John. Anybody else?
Yeah. Not yet. So I guess did you try to implement this? It sounds like a very simplistic implementation, but it was useful information that you included, which we haven't heard about last time, regarding sort of like what's in scope of the document, what's not, and specifically last time there was a little bit of confusion of like how do you manage to get this attestation information, but then there's nothing said about it. But I think that should be much clearer by now.
Good. I was hoping to clarify that. I'm happy to hear that. Yeah, so I think we have implemented something like this.
Mm-hmm.
It's not this spec exactly, but it is this technique.
Yeah.
I guess we need to.
Yeah, I guess we need to get reviewers for this document. I think that's the only approach. Okay, sorry. Yeah.
So we may actually need to pair this with a BCP that actually digs into the operating system specific stuff. So having a BCP that says, how do you get a safety net attestation? How do you get a Windows attestation? What do you do on iOS? So the core spec that we're proposing here is focused on how you transport it to the token endpoint, to the authorization endpoint, and how you would possibly further pass it on in OpenID Connect to an authentication server, because you may want to know what the app is, something about the app when you're doing the authentication, separate from the authorization in an enterprise scenario. But that should probably be kept separate from the operating system dependent stuff, which changes every 12 months. So like we did with AppAuth, where we have a BCP, we probably need to have an implementation BCP, how to do it, but that shouldn't stop us from initially adopting the core spec and moving forward with that.
Yeah, so do we have a few people who could take a look at this document, do a review, and so we can see any volunteers? I see Tony nodding in the wrong way. So we'll reach out to some of you during this week and do some arm twisting. And
great.
I think it appears to be a useful mechanism.
So one other quick point, as Ecker pointed out, we have this general problem of how do I know if I'm talking to a fake app? So this is the first thing that we've actually talked about that may actually be able to address, am I talking to the app that I think I'm talking to? Which means that our AD should actually be quite keen on us making progress with this.
All right.
Okay.
Well, thank you, everyone. I appreciate your time.
Thank you, man.
Thanks a lot.
We have time. I guess,
We have
for-
time for Justin to talk about HTTP signing.
Lots of time.
That's good.
Hi, and yes, you should read the title of the slide with a sigh. Okay, so I wasn't planning on talking about this, but I saw an interesting draft yesterday that kind of brought this thing back around. And also there's been some discussion on the mailing list about JOT-signed introspection responses and things like that. So anyway, the topic of HTTP signing, we've talked about it before. And there's this draft that I wrote years ago. It's functional. It's been implemented by several different people. It works. It's flexible, but it's also expired and completely unloved by this working group. So there's also this other draft, the Cabbage HTTP signatures. Cabbage apparently has moved on from this and somebody else has taken over editing it, but it's kind of resurrected in the last 6 months. I actually didn't know that until this morning when I was pulling this information together, but there's some more stuff in there. It's got a lot of problems in it. I humbly say that it has more problems than my own draft, but whatever. But it's a similar kind of approach, tries to be a little bit more universal and therefore runs into a little bit more universal problems. We looked at it in this working group, decided back then it wasn't really what we were looking for. And having skimmed the new version, not read it in depth, I still don't think this is quite what we're after. You can always just use JOT for everything. We already made the mistake of SOAP once. Let's not make it again. All right. The new draft that I just found out about literally last night at the RFC Lightning Talk things is Yaskin HTTP origin signed responses. Now, this is a draft that adds a signature header to the HTTP message. This is not something that is bound to any kind of like access token or particular style of API or something like that. This is something that allows you to sign an HTTP response. It does have some amount of crypto flexibility in that you can use bare elliptical curve keys or X509 certs. And it does allow you to do multiple signatures with multiple signers, which is important in a lot of HTTP systems because you've got proxies and all this other stuff, and everybody's going to want to kind of do their own thing along the way. The problem that this draft is trying to solve is, especially in the world of HTTP 2, When you've got a provider like Google that's serving a page, they want to be able to do things like HTTP2 push and include a bunch of little stuff that's actually from somewhere else, but they've cached it on the way through and they're sending it to you and stuff like that. And you want to be able to verify the content and all of that. Interesting thing about this is that the signature is also over the request, but it's only included in the response, which is to say the server that is serving the response generates the signature, but it includes like, this was the request that made me give you this response as part of that. So some really interesting mechanisms there. Downsides is that this is response only. It is written in such a way that it is only signing the response. It is not the client, the HTTP client, signing the request, which if we were to apply this to the OAuth space, that's the part that we really want. You know, we want to have a signature protection and key proof of possession around the client that is making the request to the API in the first place. This doesn't do that, but in my reading of it, and I sat down and had a conversation with the author of this draft earlier today, it could be adapted or really the same structures be reused in this space. Now, there is no body or payload protection in this. This is all like headers and URLs and stuff like that. But there's another draft, which I'll talk to in just a second, that allows you to do that kind of stuff. It is tied generally to certificates in PKI. There is kind of this little additional thing on the side that says, oh, you can use a bear key if you're doing elliptical curves. It's still a very early draft. I think that the flexibility that's already kind of built in there would allow us to have more bear key use cases. And of course, most OAuth bound keys, token bound keys, which has nothing to do with token binding, of course, but we've run out of words. Most of those are going to be bear keys anyway, and not certificates with chains and validation. Reading through the draft itself, most of the complexity that I saw, again, coming just brand new to this, was in the certificate validation, which is kind of not surprising, is, you know, making sure that the certificate's valid and it's in the right window, and there's all these like cache timeouts and stuff like that. If you're just doing this with bare keys, it's pretty straightforward. It's generating a signature, getting in the right format, putting it in the right place with the right identifiers. The draft that is referenced from that in order to allow for content protection is draft Thompson HTTP mice. And this is just basically a really clever way to use Merkle graphs and digests and things like that to protect HTTP bodies in a, not exactly in a streamable fashion, but in an appendable fashion. You can kind of chunk it up and incrementally know whether or not you've got integrity protection over the body. It's an alternative to like the HTTP like full body message digest thing, not digest authentication, but the other one. Downside, of course, is that none of this supports OAuth because they're all solving their own things. And honestly, that's kind of okay. I never wanted to have to solve HTTP signing in the OAuth working group, but it was, if we were going to be doing proof of possession tokens, which we thought we were a few years ago, we were going to have to come up with some way to do that. Other people, turns out, have this HTTP signing problem and have for years. That's why we have the Cabbage document. That's why we've got a bunch of proprietary implementations. AWS has its own weird, fragile thing. I see Anna nodding for that. So people are trying to crack this particularly tough nut. I think these two drafts have some interesting promise in the way that they're approaching the problem, and I think it might be worthwhile for us to look at that. And if we did, what we would really need to do is adapt the sign responses so that they can cover requests. It's all HTTP structures. It's all based on structured headers and all that kind of stuff. It would be a fairly straightforward to define a request header that would be analogous to the response header and how those two play nice together and all that. How that gets bound to the keys to the tokens and how that gets represented to do the signing. And we can still send our access tokens like we always have, because now we're signing a header, and we can sign like, we can sign the access token header, we can sign the date header, we can sign a bunch of other things that give us the types of security properties that we like, in addition to having message level signature protection around that request that proves that you have a particular key that is bound to that token. And we can also use the token confirmation methods that have already been started to be fleshed out in JOT, and thanks to Brian, we now have a field for that from the introspection responses due to the MTLS work. We can add in ways to say, like, from the authorization server to the resource server, hey, here's the key that you're supposed to be looking for when you're looking at validating this message, which was the POP model. If anybody remembers that document from ages ago, that was kind of the intended model of this all along. So I figured the group should know that these things exist. Like I said, I just found out that this is a thing. So I just wanted to let people know this is here. And is this something that we want to pick up again?
Thank you, Justin, for making us aware of this work. One of the questions I have on, or the problem we ran into back then with this work was that we had these intermediaries and also application frameworks that munched around with the headers and the payload somehow that rendered the signature invalid. We also had, as we focused mostly on, as the document said, signing, HTTP signing, so literally not encryption. And maybe back then we focused on symmetric as well as asymmetric keys. And now the question for me is, are we still trying to accomplish the same things, or did we maybe change our mind in the meanwhile that it's from your talk, it appears that some of the guys are more looking at the use of asymmetric crypto in the meanwhile with literally digital signatures and not use symmetric keys anymore. Or you mentioned the encryption from Martin Thompson. Maybe that's another data point. If I understand, is that?
That's not encryption. It's
not encryption? Okay.
No, it's integrity protection of the HTTP message body.
Okay. There's a
oh, is there an encryption one? Okay, so that's news to me. So apparently there's an encryption. Okay. Okay. So for on mic that it says just do AED with that same key.
Okay.
Yes. No.
Authenticated encryption with additional data.
There's only one mic now. Yeah.
Yeah. Run over there.
Yeah, I mean, so there's already, I think it's actually an RC or in the queue now, a Thompson draft about doing content encryption with a pre-shared symmetric key. So that presumably would give you because it's AED, it would give you the integrity properties you wish to have as well. I mean, so you wouldn't. I don't think it covers the headers though. It does not cover the headers, right?
Well, that's
the mice does the header.
No. So the mice is just how to do a signature, as I recall, that allows you to progressively verify the data as it comes in rather than verify it at the very end, right? Otherwise, it's just digitally signing, right? Okay. I think you're wrong about the Yaskin draft. It does cover the body. The Yaskin draft does cover the body.
No, it doesn't.
I can reread it.
I'll have to reread it.
You can reread it. This is the point. Since the point of it is to allow you to have data which is in the origin of the person who's signing it, and if you didn't cover the body, that would not be very useful. That seems unlikely.
So my understanding was that it covers the body by outsourcing it to either the mice draft or the body digest header. Yeah. So yeah, so to be clear, the Yaskin draft does cover the body if you use another draft that covers the body and then spits out a header, and then you cover that header using this.
Okay.
So this is basically this does the verb URL and headers.
Okay.
Right. And then the mice draft basically does a progressive form of a signature over the body.
Okay.
And spits that into a header.
So maybe what we should be then looking into is how we could tie this into the proof of possession work with Oauth for use with these existing documents.
That's
what you're proposing.
Yeah, that's what I'm proposing. If we want to pick up proof of possession with HTTP level message signing, this may be an avenue to do that. This is new work. This has not been adopted by the HTTP this working group at this time. I know there's going to be a presentation on the Yaskin draft tomorrow. I don't know where it's going, and I can't predict where it's going, but people are trying to solve this as well. And if there's a general HTTP mechanism that we can then say, oh, instead of using a PKI cert chain, use your access token and associated key to generate that same signature, that would really be the win that we're after.
So I don't think it's like super likely that like this is going to be adopted. In particular, the focus on origin substitution that is allowing the web PKI cert to sign the data, which is then accepted as if for HTTPS response, is like not like super popular. I mean, maybe possible that someone like will do some trimmed down version that just is tied to a pre-shared key, like a raw key. So I don't know quite what the optics that could be, but I know that the use cases Google wants like include needing the like origin substitution feature. So there was some question about there's this meeting today to sort of go over some of that stuff. So I don't know what's going to happen, but I think if what you guys want is a digital signature over the system that is just tied to a key which is established in some independent fashion that is not tied to web PKI origins, then you should probably tell HTTP that, and maybe they'll want to produce it or not.
And maybe not just the digital signature variant, but also the symmetric key variant.
Yeah, so I guess you need to cover the headers, I guess, for
the request.
So funny you should mention that. I think since they're using AED, I suppose it's possible you could modify the Thomson RFC to treat the headers as the AED.
Yes, additional data.
And while keeping much, but again, like
it's a little bit of work.
It's work, yeah.
Yeah, it's definitely work to adapt it into this space. It is solving a different but related problem in a different but related way. So it's not a simple turnkey kind of thing, but it might be something we want to pursue.
That might be an interesting topic for a dinner conversation during this week. So we'll send a mail around, not like independently, having a dinner among the Oauth folks would be useful anyway, so we could put that forward as a discussion topic. Thanks, Justin, for bringing this up.
Thank you. Okay, that's it. We're done.
Awesome.
Thank you, guys.
Do you have any other topic that you would like to raise that we should maybe talk about at the second session? Maybe on how we could actually get the AC turned up to a level that I'm not freezing in front of the room.
Aren't you from the Alps?
Apparently not. There's a microphone. Just come forward.
If we have 5 extra minutes tomorrow, maybe we could just give a quick overview of our assisted token proposal.
Or do you want to do that now? Do we have?
I'd rather have some slides, I think.
Okay.
And some rest after travel. Yeah, exactly.
Oh, we actually ran overtime, didn't we?
Yeah, we're done.
Okay. Sorry. Yeah, I also thought 5:30, so actually we ran overtime. Sorry about that.
That's fine. But yeah, for his, not sure what his document, he has slides or did he?
I think he will work on slides.
It is cold here, yeah?
Terrible cold. I would be ill at the end of the week, I can tell you.